Welcome to the deep dive. So, today we're thinking about blockchain like, well, almost like a building, a skyscraper.
Hmm.
Different floors, different functions, but it all relies on the foundation. And today we're really digging into that foundation, layer zero.
Exactly. And, most people listening probably get layer ones, your Bitcoins, your Ethereums, the main engine, so to speak.
Hmm.
And we hear a lot about layer twos, the solutions trying to make those engines faster, cheaper. But what often gets missed is what's underneath all of that.
Bedrock.
The bedrock, yeah. The actual infrastructure that lets layer ones exist and, crucially, talk to each other.
Yeah.
And maybe even layer twos eventually. That's layer zero.
Okay.
So our mission today really is to unpack layer zero. What is it? Why does it matter so much? And how does it fit with layer one and layer two? But we'll try not to get lost in the weeds of, specific chain politics or anything.
Right. We're assuming you, the listener, have a decent handle on layer one concepts, but maybe layer zero and how layer two connects, that's where the questions are. So let's just jump in. Layer zero, what is it at its core?
Okay, so layer zero, think of it as the absolute underlying infrastructure. It's more fundamental than the blockchains you usually interact with. It includes the protocols, the actual network pipes, the hardware servers, nodes, internet connections, and really importantly, the systems that allow different blockchains to connect and, well, interoperate.
Interoperate, that sounds key.
It really is. It's the groundwork for the whole ecosystem.
So if layer one is like, say, Ethereum, a big highway for transactions, what's the big problem layer zero is trying to fix down at that base level?
Yeah, the main problem is that interoperability. It's the challenge of getting different blockchains, which might be built totally differently, to actually communicate and exchange data or value.
Ah, okay, like different countries' rail systems using different track gauges.
That's a great analogy, actually. Without layer zero, or something serving that function, each blockchain is kind of stuck in its own silo. You can't easily move assets or information between, say, Bitcoin and Ethereum directly, or between two newer specialized chains.
Right, which limits growth, I imagine.
Hugely. Layer zero aims to provide this sort of universal standards or secure bridges needed for these separate networks to interact. It makes the whole space more connected, more powerful.
Makes sense. So what are the actual building blocks of this layer zero? What components make it up?
Well, there are a few key parts. A big one is what you might hear called interoperability protocols, sometimes called CCIPs, cross-chain interoperability protocols.
Okay, CCIPs.
Yeah. And these are basically sets of rules and secure messaging systems that let chain A talk to chain B, even if they're totally different under the hood. Think of them like, I don't know, universal translators.
Translators for blockchains. I like that.
And then, of course, there's the actual physical stuff, the hardware, servers, the nodes running the software, the internet itself. All that foundational stuff is part of layer zero, too.
Got it. Physical and digital infrastructure. Can you give us some examples, like actual projects that operate at layer zero?
Sure. Polkadot is probably one of the most well-known examples. Its whole design is centered around this layer zero concept.
So both Cosmos and Polkadot are heavily focused on connecting chains. Different approaches, maybe, but similar goal.
Very similar core goal, yes.
Yeah.
Solving that interoperability puzzle. Avalanche is another interesting one, though its structure is a bit different again.
So?
Avalanche uses what it calls a tri-blockchain infrastructure. 3 core chains.
Wow, okay. 3 chains working together.
Yeah. The idea is that by separating these functions, they can optimize for speed, low fees, and high transaction volume, especially for things like cross-chain swaps within its own ecosystem. It's built for performance.
So different ways to build that foundational layer. Are there other, maybe less platform-specific technologies that act like layer zero components?
Oh, absolutely. Things we almost take for granted, like the peer-to-peer networking protocols that let nodes find and talk to each other. That's layer zero stuff.
Right, basic internet plumbing in a way.
Kind of, yeah. And gossiping protocols, the methods blockchains use to spread information efficiently across the network. And we're also seeing these specialized modular layers emerging, like Celestia, focused just on data availability.
Data availability.
Yeah, making sure that all the transaction data is published and accessible, which is crucial for security, especially for layer twos. So these can act as a sort of foundational data layer, a layer zero service for other chains or rollups.
Okay, so if we had to boil down layer zero, what are its main defining features?
I'd say the 2 headline features are scalability, providing a base that enables scaling, and of course, interoperability, connecting the disconnected.
And security is baked in there too.
Definitely. They achieve this through robust consensus mechanisms, often proof of stake, and advanced cryptography right at that foundational level. Security is paramount.
Okay, that paints a much clearer picture of layer zero, the foundation, the connectors, the enabler. Now, how does this sit relative to the layer ones everyone knows? Bitcoin, Ethereum.
Right. So if layer 0 is the foundation and the underlying network grid, layer 1 is the main power plant or the main highway system itself. It's the core blockchain network where the actual transactions get processed, verified, and recorded permanently.
The engine of the car you said earlier.
Exactly. That's where the primary work happens.
And the key parts of that layer one engine.
You've got the consensus mechanism, proof of work, proof of stake, how everyone agrees on the state of the ledger. You have the native token like BTC or ETH, used for fees and maybe staking. And for many smart contracts, the ability to run code on the blockchain.
So Bitcoin, Ethereum, Solana, these are the platforms actually doing the transaction validation, running the dApps, maintaining that single source of truth.
Precisely. They handle the core functions, processing, consensus, security for their own chain, and maintaining that immutable ledger state. They operate on top of or using the kind of infrastructure layer 0 provides or aims to standardize.
Got it. Layer zero enables, layer one executes. So then layer two, where does that fit in?
Okay, so layer 2 solutions are built on top of layer 1. Think of them as express lanes or auxiliary processing units designed purely to make layer 1's work better.
How so? Better how?
Faster and cheaper, primarily. They aim to increase the number of transactions a blockchain ecosystem can handle the throughput and drastically reduce the fees, especially during busy times.
But they don't replace layer one.
No, absolutely not. That's key. They inherit their security from layer 1. They essentially take a lot of the transactional work off the main layer 1 chain, process it more efficiently, and then report back or settled results on layer 1.
Okay, taking the load off. How do they actually do that? What are the tricks?
Well, there are a few main approaches. One is simply doing transactions off-chain. Imagine opening a tab at a bar, lots of drinks ordered, but only one final bill settled at the end. State channels, like Bitcoin's Lightning Network, work a bit like that for payments.
Okay, like a private channel.
Exactly. Then you have rollups. These are really popular now, especially on Ethereum. Things like optimistic rollups and ZK rollups.
Roll-ups, they bundle transactions.
Yeah, that's the basic idea. They bundle or roll up hundreds or even thousands of layer 2 transactions into a single compressed piece of data that gets submitted back to the layer 1 chain. It's much cheaper and faster than putting every single one of those transactions on layer 1 individually.
Ah, okay. Efficiency through batching, essentially.
Right. Optimistic rollups assume transactions are valid unless challenged, while ZK rollups use complex cryptography zero-knowledge proofs to mathematically prove the validity of the batch without revealing all the underlying data.
Fascinating. So layer two is really about making blockchains practical for like everyday use cases where you need speed and low cost.
That's the driving force. As networks like Ethereum get more popular, the main chain gets congested, fees go up, things slow down. Layer 2s are crucial for scaling to handle potentially millions of users without sacrificing the core security layer 1 provides.
Can you name a couple of big layer twos people might know?
Sure. We mentioned the Lightning Network for Bitcoin, focused on payments. For Ethereum, you have big players like Arbitrum and Optimism, both using optimistic rollups. There are also ZK rollup solutions gaining traction like ZK Sync and Starknet.
And you mentioned sidechains briefly too. How are they different?
Yeah, sidechains are a bit different. They're separate blockchains that run alongside a layer 1, often connected by a two-way bridge. But crucially, they usually have their own consensus mechanism and security model, so they don't inherit security directly from layer 1 in the same way rollups do.
Okay, so more independent, potentially less secure depending on their own setup.
Potentially, yes. It's a different trade-off. More flexibility, maybe, but you're relying on the sidechain's own security.
Right. Okay, so we've mapped out L0, L1, and L2. Let's just quickly tie it all together. How do they interact?
Okay, recap. Layer 0 provides the foundational network fabric and aims to enable interoperability between multiple layer 1s.
The connectors.
The connectors, yeah. Then layer 1 provides the core security, the consensus, the final settlement layer, the source of truth.
The main highways.
And layer 2 builds on a specific layer 1 to handle transactions more efficiently, reducing costs and increasing speed, but ultimately relying on that layer 1 for security and finality.
The express lanes.
Exactly. Layer 1 secures, layer 2 scales.
And you hinted earlier that layer 2s might even start using layer 0 tech directly.
Yes. That's a really interesting emerging trend, especially with modular blockchains. You might see a layer 2 rollup, for example, that focuses purely on executing transactions, but uses a separate layer 0 network, like Celestia perhaps, just for publishing its transaction data securely and cheaply.
Wow, so layers using other layers. It gets complex, but you can see the specialization.
It does. It allows each layer to focus on doing one thing really well. Execution, settlement, data availability, consensus. They can potentially be separated and optimized.
So understanding these layers really helps make sense of how the whole blockchain world is trying to solve its big challenges, right? Scalability, different chains working together.
Absolutely. It gives you a framework. Instead of just seeing a jumble of project names, you can start to see the architecture, the different roles these technologies are playing in building out a more capable and interconnected, decentralized web.
Fantastic. Well, this has been incredibly clarifying. Just to quickly hit the main points again. Layer 0 is that base infrastructure focused on enabling communication between chains.
Right. Interoperability and the base network.
Layer 1 is the core blockchain itself, security, consensus, the main ledger.
Bitcoin, Ethereum, the engines.
And Layer 2 solutions sit on top of Layer 1 to make things faster and cheaper, handling transactions off the main chain.
Scaling solutions like rollups and channels. Spot on.
Perfect. So here's maybe a final thought for you, our listeners, to chew on. As these layers 0, 1, and 2 continue to develop and interact in more sophisticated ways, perhaps even blurring the lines sometimes, how might that reshape not just crypto, but potentially other areas of technology in our online lives? What kind of truly seamless, scalable, and interconnected applications could emerge when you move beyond thinking about single chains and start seeing this integrated, layered ecosystem? Something to ponder.
Definitely food for thought.
Thanks for joining us for this deep dive.